Yes, welcome. So here I am going to discuss Lagrange's method of undetermined multipliers. This is the last concept of a function of several variables. So let's see quickly the working rule. So working rule, suppose it is required to find the extreme for the function f of xyz subject to the condition phi of xyz equals to 0. Okay. Then step 1, form Lagrangian function capital F of xyz equals to f of xyz plus lambda into phi of xyz. Okay, this function, this expression is known as Lagrangian function. The function you need to express in this format. Okay, so what is the format? F of xyz equals to f of xyz plus lambda into phi of xyz, where lambda is called the Lagrange multiplier, which is determined by the following conditions. Step 2, obtain the equations. Okay, means here whatever the Lagrangian function format you are writing, this function differentiate one time with respect to x, therefore you are getting equation 2. Then you differentiate with respect to y, equation 3. Differentiate with respect to z, then you are getting equation 4. Then your task is to solve these equations, equation 2, 3, 4, to get corresponding x, y, z values. Okay, this is the simple task. Only thing is the given function you need to write in Lagrangian function, then you differentiate one time with respect to x, y, z, then solve for 3 equations to get x, y, z values. So let us proceed with the problem. First one, find the minimum value of x square plus y square plus z square given that xyz equals to a cube. Yeah, here they are given two expressions, right? So the first expression, x square plus y square plus z square, you take it as u. Okay, and the second one, xyz minus a cube, you take it as phi. Okay, and equation 1 and 2. Consider Lagrangian function. Lagrangian definition is capital F of xyz equals to, here you write with respect to u1 phi, that is u of xyz plus lambda into phi of xyz, equation 3. Now your u of xyz means, by using equation 1 you can write x square plus y square plus z square plus lambda of phi is nothing but equation 2 xyz minus a cube. Now you go for derivatives. So dou u by dou x plus lambda into dou phi by dou x, means you are differentiating the Lagrangian function with respect to x. So this is your u and this is your function phi. So dou u by dou x, the u function u you are differentiating with respect to x, it gives 2x plus lambda into, so phi if you differentiate with respect to x you are getting yz, 2x plus lambda yz equals to 0. So this is your equation 5. Next the same equation 4 you differentiate with respect to y, then dou u by dou y plus lambda into dou phi by dou y equals to 2y plus lambda xz, you equate it to 0 and take it as equation 6. Similarly go for differentiation with respect to z. So equation 4 if you differentiate with respect to z, then you are getting dou u by dou z plus lambda into dou phi by dou z equals to 2z plus lambda xy equals to 0, equation 7. Then here you need to solve equation 5, 6, 7 to get x, y, z values. From equation 5 you are writing expression for x by yz and its value x by yz is minus lambda by 2. From equation 6 you write expression for y by xz, then its value is minus y by minus lambda by 2. And from equation 7 if you take expression for z by xy, its value is minus lambda by 2. Then equate it one another, that is equation 8 and 9 if you equate you are getting x square equals to y square. Equation 9 and 10 if you equate you are getting y square equals to z square. It means that x square equals to y square equals to z square it means x equals to y equals to z, equation 13. So this equation 13 you substitute in the given function. So given function is xyz equals to x cube. From equation 13 we know that x equals to y, y equals to z. It means that x cube equals to a cube, that means x value a, y value a, z value a, right? So this x value a, y value a, z value a you substitute in one more given function, therefore your u equals to 3a square. Okay, go to the second problem. Find the maximum and minimum values of x plus y plus z subject to 1 by x plus 1 by y plus 1 by z equals to 1. Same thing, the first function you consider as u and second function as phi. Then you write Lagrangian definition, f of xyz equals to u of xyz plus lambda into phi of xyz. Differentiate equation 3 with respect to x, y, z. Okay, so then here you are just substituting corresponding functions. U of xyz means given x plus y plus z. Phi of xyz means from given data 1 plus 1 by x plus 1 by y plus 1 by z minus 1. Then go for finding the derivative with respect to x, y, z. So that is with respect to x, dou u by dou x plus lambda into dou phi by dou x. So u, if you differentiate with respect to x, you are getting 1. Then phi, if you differentiate with respect to x, you are getting minus 1 by x square. Therefore 1 minus lambda by x square equals to 0. You take it as equation 4. Similarly, you differentiate equation 3 with respect to y, then you are getting 1 minus lambda by y square equals to 0. Take it as equation 5. Then finally you differentiate with respect to z, therefore you are getting 1 minus lambda by z square equals to 0, equation 6. Solve equation 4, 5, 6 simultaneously. If you solve, so x value is plus or minus square root of lambda, y value is also plus or minus square root of lambda, z value is also plus or minus square root of lambda. So corresponding equation 7, 8, 9. Then you add it, equation 7 plus 8 plus 9. So these values, x, y, z values, if you use in equation 2, you are getting 1 by square root of lambda plus 1 by square root of lambda plus 1 by square root of lambda equals to 1. Means if you solve, your lambda value is 9. Okay, use this lambda value in x, y, z. So therefore your x value is plus or minus 3, y value plus or minus 3, z value plus or minus 3. Okay, thus the maximum and minimum values are plus 9 and minus 9. So this is the way of solving. Okay, in the same way you please try to proceed and solve and try to understand the remaining problems based on Lagrange's undetermined multipliers. Okay, with this I am concluding the videos. Okay, thank you for watching this.